In 1878, a Czech physicist named Vincenc Strouhal strung wires on a frame, spun them through the air, and listened. The pitch depended only on how fast the wire moved and how thick it was. He was hearing vortices. A century later came something stranger. You do not need the equations of fluid motion to get a fluid. 9 numbers per cell, a rule for mixing them, a rule for passing them on. That is all. Here is the entire machine. Every cell of the grid holds 9 counters, 1 for each direction a particle might move. Still, north, south, east, west, and the 4 diagonals. Each step, nudge the counters toward the equilibrium that the local density and speed demand, then slide each counter 1 cell along its own direction. Collide, stream, repeat. Nothing in that code knows what a vortex is, and yet. A cylinder in a stream. Watch the speed first. The fluid crowds around the sides, and behind the cylinder it almost stops, leaving a slow, ragged shadow. Now the pressure. The nose glows. That is the stagnation point, where the flow slams to a halt. And look at the dark spots peeling off behind. Every one is a low-pressure core. Now the field that shows what those really are. Vorticity, the spin of the fluid at every point. Blue turns one way, amber the other. There is your wake. 2 conveyor belts of spin tearing off in turn. But it does not always do that. There is exactly one number that decides, the Reynolds number, inertia divided by viscosity. Set it to 30. The wake stays glued to the cylinder. 2 vortices, stuck, symmetric, going nowhere. Now 48. Watch closely. The wake wobbles. It really does. 5% of the inflow speed. And then slowly the wobble dies away. Below the threshold, a disturbance is punished. Now 70, the same wobble, and this time it grows and never stops. Somewhere between 48 and 70, the fluid changed its mind. The threshold sits near 50. Push past it to a Reynolds number of 120, and the street finds a rhythm, 1 vortex every 946 steps. Take that frequency, multiply by the cylinder's width, divide by the flow speed. The units cancel. What is left is Strouhal's number, 0.201. For a real cylinder in real air, the measured value is about 0.2. Nowhere in this code is that number written down. And it does not have to be a cylinder. Draw anything. Here is a plate, tilted into the wind, painted into the channel, 1 brush stroke at a time. It measures itself, 46 cells across, recomputes the Reynolds number from what you drew, and grows its own wake, a fatter, slower street, shedding at a Strouhal number of 0.28. Not the cylinder's number, its own. Wind at 10 meters a second past a 2-millimeter cable. Vortices come off 1,000 times a second. That is the note Strouhal heard, and it is why power lines hum. None of it was programmed. It fell out of 9 counters and 2 rules. The link is on screen. Draw an obstacle and find the threshold yourself.